we'll just get started. So we're moving on after our first exam. Hopefully it went well. We are talking about predicting the amounts of reactant that's needed to make a certain amount of product, or predicting the amount of product that you get from a certain amount of reactant, right? So remember, right? Which one is on which side, right? Reactants form products. So let's see here, right? Reactants form products. So reactants are always on the left-hand side, products are always on the right-hand side. But it's important because no way any manufacturer, whether it's a, I don't know how I picked this, herbal colon bowel formula movement, or a more interesting, a beer kit, no way are they going to give the exact amounts of everything so that, you know, you get everything's used up. There's always stuff that's left over in reactions, and it gets kind of complicated. But we're not worried about that yet, right? Because just imagine if you have a whole bunch of reactants, not just one, but a whole bunch of them, one of those is going to react up first. So that's a whole other problem. That's the next class period. We're going to assume that whatever the reactant is, it completely gets consumed and forms products. So let's convert all of the reactant to products. That's a lot easier. In fact, it's just half the work is all. But it's interesting and it's powerful. So let's get started. It starts with these reactions, right? How do you read this reaction? Oh, Paul, how would you read that reaction? Like to what? Yeah, that dinitrogen pentoxide, but to what? Is it 2 grams? To what? What's the unit? They're ratios, right? Like you get 2 dinitrogen pentoxides for every 4 nitrogen dioxides, or for every 1 oxygen. But what's the ratio? What would it be? Anybody know? Moles. Moles is the best answer. But what I was hoping you'd say is 2 of those molecules, right? 2 of those molecules of dinitrogen pentoxide have to actually collide in space, physically collide in space, interact, and then out pops out 4 nitrogen dioxide molecules and 1 oxygen. Except if we want to work out problems, we're going to be messing with essentially grams in the end. And geez, that's a gazillion molecules. So we work with mole ratios instead of talking about molecules. It saves a one big step. So we can talk. So how would you read it? You could read it as, I think like Connor said, would be the best way to read it. 2 moles of nitrogen dioxide react to produce 4 moles of nitrogen dioxide plus how many moles of oxygen? Just 1. Right? Just 1 mole of oxygen. Okay. So what are the mole bridges or ratios that can be obtained from this equation? Lauren, I want to get a ratio. Well, before we start with the ratio, I think it's easier when you start with equal signs. Like if I say 2 moles of dinitrogen pentoxide, that would equal how many moles of NO2? You would say, according to the ratio here, 2 moles of dinitrogen pentoxide, you get how many moles of NO2 according to the reaction? 4. Okay. But equal signs aren't, you know, ratios. So let's make it a ratio. 2 moles dinitrogen pentoxide for every 4 moles of NO2. So that's one, we call them mole bridge, right? You're just converting, in this case, if you use this ratio, you'd be converting moles of NO2, and then you remember in the big long box we're going to be doing, you'd be converting moles of NO2 to moles of what, Giselle? You'd be converting to moles of, not oxygen, dinitrogen pentoxide. Okay. And it'll make more sense when we start doing a bunch of these, but first let's just recognize all these mole ratios. There's some more in there. Megan, what would be another one?
2 dinitrogen pentoxide to 1
2. And don't. Oh, see, I said it how. To 1. What'd you say? Oxygen.
Mole.
Yeah. Use the word mole, because it'll make the converting so much easier. What would be another one, Rebecca? What would be another ratio you can get out of this mess? From up here. What would be another ratio? Another mole bridge you could get? What to what? What was that? Like maybe instead of working with the 2 moles of dinitrogen pentoxide, work with something else. Like how about these 2? Oh, how about these 2? What would be their ratio? Right. 4 moles of NO2, nitrogen dioxide, to every, not 2, 1, right? They never write the 1s. So these ratios that we're drawing from are right here. These are those mole ratios. All right, not the subscripts. Okay. So let's try a few of these problems here. If 4 moles of dinitrogen pentoxide react, how many moles would you say, Stephen, of nitrogen dioxide are formed just by looking up there? Can you do it in your head? He says 8, right? Man, I'm so bad at doing stuff in my head. He's probably right, right? 4. I'd have to do it in my head. I can't do it in my head. I have to do it this way. I make the box. Let's see if he's right. 4 moles of dinitrogen pentoxide react. I have to convert that all the way to moles of NO2. So I need to pick the right mole bridge. What mole bridge would I pick, Kendall?
The 2 moles of the dinitrogen over the 4 moles we flip it.
Okay, so what you're saying is put the moles of dinitrogen pentoxide on the bottom, right? And how many of them?
But you put like 2.
Like 2, exactly, because that's the number that's in front of it. Then on top, you'd put the
4 moles of nitrogen.
Yeah, the 4 moles of nitrogen dioxide. All right, so 4 times 4 is 16 divided by 2 is 8. Yes, shit. Stephen can do stuff in his head better than I can, right? 8 moles of NO2. He's exactly right. Okay. How about this next one, Alyssa? 3 moles of dinitrogen pentoxide react. How many grams of NO2 are formed? So if you want to do this whole box dimensional analysis thing, where would you start? Yes. 3 moles of dinitrogen pentoxide. Draw our box thing, right? And then, Stephanie, what would you do next?
Use the mole bridge.
Yeah, which mole bridge would you use?
2 moles of N2O5.
The 2 moles of N2O5. Now that would has to go on the bottom. Good. See how she's making those units cancel? Then on top you're going to put 4 moles of NO2 because you want to end up in NO2 in the end. Perfect. Okay. If I quit right now, Kenneth, what would be the units? What would be the units of my answer if I quit right now? It would be the units of my answer if I quit right now. Yeah, it would be the units of my answer. It would be moles of NO2, right? If I quit now. Can't quit now, though, Manuel. I got to get all the way to grams of NO2. So what do I do? What could I do? What could I do? What's the word for it? The technical word, the technical jargon, since we're budding chemists here? Find the molar mass of NO2, right? Because then Molar mass is what's used to convert grams to moles or moles to grams. So nitrogen is, what, 14, and 2 oxygens, that's 32. That should be like 46. So the 46 grams, Enrique, is going to go on the top or the bottom?
The bottom?
Did I say 46? Yeah, 46. On the bottom makes sense? Yeah, see how the units won't cancel, Enrique? See that? So to me, what I like to do here, let's get a darker color. What I like to do here is, before I even mess with stuff, I'll put the unit down here. Right? Because I know that unit has to go down there. Don't put a number, though. Don't put a number in front of the unit. Just put the unit down there. And then it's, oh yeah, it needs to be in the grams, so then I'd put the 46 grams up on the top. And how many moles of NO2? For molar mass, it's always what? A 1. For molar mass, it's always a 1. See what's a common mistake? You want to put a 4 in there because you see a 4 up here? That's only for mole bridge. 4 to 1 or 4 to 2, right? Okay. So I'm done. Everything cancels but the grams of NO2. So 3 times 4 divided by 2. Three times 4 divided by 2 times 46, about 276 grams of NO2. Okay. All right. Emily, does that make sense? Okay. Let's pick on Lorena. Lorena, we got to convert. We want 2.8 grams of N2O5 react. Where's our reaction? Clean this up. 2.85 grams of dinitrogen pentoxide react. We want to know how many grams of NO2 are formed. Where would you start? Yeah, I agree. Write down this. We're going to start with the 2.8 grams of dinitrogen pentoxide. Convert all the way to grams of NO2. So now it would be the first step. Bowdy, what would be the first step?
Do you have to convert to moles?
You got to convert it to moles. So we can use the what bridge? The mole bridge. You got to convert it to moles. So if you wanted to see the whole story here, sometimes that helps me. I put in all the units with no numbers. So she's right. You got to convert to moles first. So it would look like this. And then we got to get it into moles of this dinitrogen dioxide. Get it into the moles of the nitrogen dioxide. So that means mole bridge. Then the very last step would be, what's the word for that? Audrey? What's the word for this very last step? To convert the moles of this NO2 into grams. Molar mass. Molar mass. Molar mass. The terminology helps if you remember the terminology. Molar mass is what's used to convert moles to grams or grams to moles, the other way around. So put in the numbers. Put in the numbers. See what you get as an answer. Sydney, did you get an answer? Not yet? Megan got an answer. What did Megan get? 2.385. That's what I got. I wanted to... So 2.4, 2.39, 2.385, whatever you reported your answer to, since we're not worried about sig figs. Okay. Make sense? Paul, you see what to do? All righty, let's go to the boards and see if we can do it then. All right? So here's our first question. So grab some chalk, some space, spread out as much as you can. We've got more chalk up here if you want some new stuff. Nitric acid is manufactured by the Ostwald process, in which nitrogen dioxide reacts with water. How many grams of nitrogen dioxide are required to produce 7.5 grams of nitric acid? Okay, so give it a shot. Yeah, it's that on button. I've done that before, Paul. No problem. Yeah, so where would you want to start? Yeah, I would start with that 7.5 grams of nitric acid and do the converting. It's exactly what I would do. I would start with this. Now watch your units. Your units tell you what step to do next.
Sometimes I like to write it down and then we do it on the phone. Because when we go fast, then I don't remember.
Yeah, whatever works for you, but going up here is what seems to work for a majority of people. But if it doesn't work for you, I'm not going to force you. Might want to write tiny because these problems are getting long. Yes, you had 3 oxygens, a nitrogen, and a hydrogen. But then you got to keep going, right? Because then this mole HNO3 has to go up here. You do that mole bridge thing to get it into the moles of what you're interested in. Right? So the mole HNO3 has to go on the bottom. Good, good. You're doing it right. Keep going. Okay. Right? So keep going. So your units, moles, don't put a number yet. Right? Just put the unit, mole HNO3. You want to get it into NO2. So that means you have to use mole bridge. So the HNO3 to the moles of NO2. Right? So you get that from the reaction, that ratio. Yeah, then you're going to have moles of NO2. And what's going to be up here? Because you want to end up in grams. So it's going to be that molar mass. Yep. Good, good, good. Looks good. See most everybody agreeing. 46, yep. Okay, so for in this first one, what are you guys getting? Like 8.2? I see, good, I see a lot of 8.2s. The final answer. Did you get it? If you got 8.2 and the folks around you got 8.2, go on to the next one. Make sure it makes sense though, before you move on. Let's see. This is good. So then multiply everything on top, divide by everything. Oh, you got it? Okay, good. So Lauren, you got it? Okay. Stephen, you got it? Excellent. Fantastic. So go on to the next one. Let me bring it up. Yep. What's up, Kenneth? Oh, whoop. Yep.
When it says 432 kg of propylene and excess NO, how do we write that exactly?
Okay, so the excess NO just means that you have got a lot of extra of it. So you don't worry about it. All this stuff is going to disappear first.
Okay.
So just kind of disregard that.
Okay.
Now, on this next one, Kenneth has a good question. What does this excess NO mean? It just means that you've got two reactants, right? And you've got a lot of NO, so don't worry about it. You've got excess, extra. You have plenty. All of this stuff is going to react up first. So we don't worry about it. So you just disregard it.
For now or forever?
Forever.
Forever? Okay.
Yep. Because you have excess. So start with that 452 kilograms of propylene. That's where you got to start. So what's the first thing you're hopefully doing in this problem? You're converting to grams. Good. Convert to grams so then you can convert to moles. Because molar mass is always in grams per mole, not kilograms. So see who remembers that ratio. Remember, the number always goes with the prefix except for kilo. So 1,000 goes with the grams. Yep. 1,000. 1,000. Yeah, so a kilogram of this stuff is 1,000 grams of that stuff. And it would be more, it's easier to see what to do if you write in the rest of the units, like kilograms of C3H6. See like how Lauren's doing it? Because then it's easier to see that what to do next, because the units are going to cancel. Now she's going to write hopefully 1 mole of C3H6 up here. Because we're going to be converting from one compound to another, and it's going to get messy. Okay. You're exactly right, except we got to get into grams first. See, that's grams. So maybe just spread it out a little bit. So we got to convert kilograms into grams first. See, because kilograms won't cancel with grams. Now here, 1 kilogram of this stuff is 1,000 grams of that stuff.
Oh, I thought you would multiply by the.
Yeah, you will multiply it by 1,000, but don't do it. Don't do it yet. Do it in the calculator. That's just 1,000. All right, and then so it'll be that times that divided by this times that divided by that times that. Okay, then you do your mole bridge. Oh yeah, you can get molar mass. You're right, Paul. You got your molar mass. Yep. Okay. Okay, now you're doing mole bridge. No, this is moles of that. Oh, you got it down there. Okay, for that, to what compound do you want to get it into? That's C3H3N. So what's the ratio? Moles of that stuff in the mole bridge.
There's 4 of them.
4 of them, so 4 moles. Don't forget that, you have to write the MOL. Otherwise you're going to forget to do molar mass. Because now you're in moles. So
Am I done now?
well, if you could check. Kilograms, kilograms. Grams of C3H6, grams C3H6. Moles C3H6, moles C3H6. You're in moles of this. So you have one more step. Molar mass of this stuff to get it into grams. Because they want
Oh,
grams.
so then we put 1 mole.
Yeah. You see that was 42? Like 39, 53. These guys are getting 53 for their molar mass of that stuff. Right? Yeah, 50. Yeah, they're getting 53. So, oh, but you're doing NO. They want to get it into acrylonitrile. So you have to look in the. They want C3H3N. Yeah, so right here is where we messed up. You're right. If it would have been grams of NO, this would have been right. So right here, we have to convert that to want C3H3N, and it's 4 to 4. That's what you need. Okay. 5.7 times 10 to the 5th. Wow. I see a lot of answers as 5.7 times 10 to the 5th. Okay. If you can get it, make sure you can get that answer. So you see where those numbers are coming from, though?
I don't see where this one came from.
So this is grams of C3. It's kind of like up here. So whenever you want to convert, you want to use the mole bridge so you can convert from one compound to the other. So here we're converting from C3H6 to what they wanted, and that's that C3H3N. Yeah, you need an N in there, C3H3N. Yeah, so they want to convert from C3H6 to C3H3N, so you have to use the mole bridge, and those are the ratios from the reaction. So you got to get into moles first. So you start out with kilograms. You got to get it into grams. See how they canceled? Kilograms are gone. Now you're in grams. But you got to get into moles, so you can use the mole bridge. So that's what this is, molar mass. So you take the chemical formula, C3H6, and just add it up on the periodic table. 3 times carbon and 6 times hydrogen. And carbon is 12, and so 36 and 6 is 42. And then see how now the grams are gone. Now you're in moles, so now you're ready for the moles to cancel. But now you're in moles of the C3H3N. But you got to go all the way to grams, because that's what they want. So you got to find 3 carbons, 3 hydrogens, and 1 nitrogen. Add it up, and you get, I guess, 53.
Yeah.
And then everything works. Then you stop, because you're in the grams of the right answer. And everything on top multiply, bottom divide. So keep going. Now the next one has the answer. For part B, the answer is 13.1. See if you can get 13.1 for part B. Make sure this makes sense. The more you practice in this room, the more comfortable you'll be with this stuff and the easier the homework will be. But now is the time to ask if you're not sure why you're doing something. Ask me or the person next to you.
This one, we started the moles already. Do we just where like hold on? We've read a point.
So if you start with moles already, you're ready for mole bridge.
We register like here or what?
So we'll start with there. And the units will tell you what to do.
Okay.
See Lauren? What's her name? Stephanie. No, Ashley. See, I think it's a healthy way to do it. See, she just put all the units down, because then the problem is so much more straightforward. And then she put in the numbers. Right? She put in all the units, because then you just fill in the numbers when you're done. You want to go to moles of that C3H6. And then the mole bridge. See that? So this would be molar mass first, so you'll have moles up here. C3H6. Then you're ready for the mole bridge to get into the moles of what you're interested. And then it'll be molar mass of that compound. If you're just going to do the units, don't worry about it. Just put in all the units. So the moles of C3H6 to the moles of what you're interested in. Moles though. Otherwise you forget to do the molar mass. And then the last step, moles of the molar mass.
And then 1 mole of that is equal to whatever grams are.
Grams of it. So I think this is faster, because then you just, all the calculator stuff.
So then it's 1 mole is 4 here.
Yeah.
No, not 1.
Professor, I set it up before I put the numbers.
I think it's better to do it this way, because then you can do all the calculator stuff at one time. Like this is going to be molar mass of this stuff, so you add up 3 carbons and 6 hydrogens. Here, do the same thing with NO.
Okay,
right?
so I have it right.
Yeah, and now you just put in the numbers.
Okay.
Molar mass always has a 1 here. Sorry, a 1 with the moles. And you put in the mole bridge. I think it's healthier to do it that way.
And then we have to go to grams.
So I really think it's faster to do it this way. Just do all the units, because then you do all your calculator stuff at the same time. You find the molar masses and you find the mole bridge. I think it's faster. Less likely to make a mistake. Yep.
How do we do this? Like if 23.2.
Yeah, this is the type of problem we're going to attack in the next class period.
So don't do it.
Well, either if you're not sure, just go on to the next one.
Okay. You got any idea? Like, you know, we did the two problems basically. You know, we did this.
Does this make sense, Rebecca? Practice. Practice makes perfect. You need a pencil? I can get you a pencil. Keep going. The more practice you get out of this, the better.
No spot on the chalkboard, then she stole your pencil.
Let's see. Where's a different one? When you get to D, D is a good one because it's a little bit of a twist.
Where do you put the grade versus?
For D? For D, it's actually a short question because you're already in moles. The units tell you what to do. So you're ready for mole bridge already. So I would start with that 0.03 moles of C3H3N, and already now the next step is mole bridge into what you're interested in. Yep.
I keep getting like
Let's see. Well, you're supposed to get what?
13.
13. Okay. Moles 3642. The ratio is 6 to 4. Right? NO is, where is it? NO is 6 to 4. Oh, here it is. 16 plus 14 is 30.
That's why. There goes the difference.
Yeah, there it is. Okay. Yep. It's not so bad, is it?
So then for E, do you need to do like a balanced equation in order to...
For E, you really don't have to worry about it, but I can tell you how to do it. You pretty much have to pretend this wasn't even there, and you do the same problem twice. You get your answer with this one, get your answer with that one, and you pick the smallest one. That's all we're going to... In fact, that's the next class period. We're going to do the exact same thing, except it's going to be twice the work, and we pick the smaller answer. Yep. Yeah, exactly. So you jump right into mole bridge.
So you just do that.
And then you need a molar mass step because they want grams at the end, right?
Grams.
Yep.
This is what it's supposed to be?
Is there an answer down there?
Yeah, writing it right now. Okay, good. Do we add what the two answers are?
Oh, you're doing E?
Yeah, I'm doing
Okay. So if you're ready for E, you really don't need to worry about it right now. So let me write "don't worry about," but I can tell you how to do it. In fact, E is going to be Monday. And Monday, they're going to give us these problems. They're going to give us all the amounts of all the reactants. So what you have to do to handle problems like E, you don't have to do it, this isn't going to be on the quiz, but just to let you know, to handle problems like E where they give you the amounts of all these different reactants, you have to calculate the answer for everything they give you. And then you just pick the smallest answer. So it's going to be twice the work on Monday, so just to let you know. So that's why you really want to get good at this, because it's going to be the exact same thing on Monday, but just pretty much twice as much.
Hey, sir, can we like stop after the tungsten one?
Can you check my work?
Tungsten's one's the last one.
Is it? Oh, I was paying attention. I was doing the E one and I didn't see it.
Yeah, you don't need to do the E one.
Like, sir, I already did it. That was the second.
Did you pick your smallest answer?
Okay, this is small. I thought we were supposed to add them together.
Yeah, you pick the smallest answer, and that's going to be it. Man, if you can get that tungsten one done, you are flying in this. I think you should be acing that quiz on Monday if you get the tungsten one done. Mia's got it done, right?
Looks like you wrote wow.
Hmm?
I said now, looks like you wrote wow.
No.
For wow. Did anybody get an answer for this last one? I thought Kenneth finished it. He took off. Did you get an answer for the last one? Anybody get an answer for the tungsten one?
Doing it now.
Did you get an answer? No? Mm-hmm.
I want to ask you, did I write this correctly? 481,000.
So you move it over 3 places. That's 4,000. You move it over way too many.
It's kilogram, right?
So you move it over from the decimal point.
Yeah. Kilograms per 1,000. 30 seconds. 48.
So did you get an answer for the last one? Oh, you start with kilograms, but then you have to go to grams, then use molar
Oh,
mass.
then yeah, that's why I moved
Oh, E don't worry about.
it. Okay.
Don't worry about for a while.
Okay. It's 4.
There you go. What'd you get? So about 1.4, 1.5 times 10 to the... Get an answer, Connor? 1.46 times 10 to the 5th.
Genesis, right?
Mm-mm.
Yeah, that's
This is what Connor got. Oh man, I bet you that's the answer then.
I got 1.47.
Yeah, somewhere around there. All right. You get this. I think, man, you should be acing that quiz on Monday. So have a good weekend. If you didn't get this, let me help you out.